In section 11.1, we're going to go through and talk about sequences as functions. And we're going to look at two separate sequences. The first one will be an arithmetic sequence, and the second one would be a geometric sequence. So an arithmetic sequence is a set of numbers in a particular order with a common difference. Okay, so if you look at this example here, what we have is 2 chips, then we have 5 chips, then we have 8, 11, and 14. So what I'm doing here is I'm adding 3 to the previous number. That's an example of arithmetic sequence. Okay, so when you're looking at arithmetic sequences, you're looking for the common difference. So what is the common difference between these two sequences? Well, in the first one, it looks like I'm adding 1.5. So a positive 1.5 to the previous number. In the second sequence, it looks like I am subtracting 9. So minus 9 from the previous number. So that is the common difference between your arithmetic sequence. If we look at the sequence here that is an arithmetic sequence, we want to plot the first 5 terms of the arithmetic sequence. So in plotting the first 5 terms, the first thing we need to do is get the next 2 terms. So I have 5, I have 3, I have 1. Looks like I'm subtracting 2 from the previous number. So negative 1, negative 3. Okay, so those are the first 5 terms of my sequence. What I want to do is I want to plot this on my graph. So let's go through and create the axes. As I go, the first number, the x-coordinate would be 1, 2, 3, 4, and 5, and the y-coordinate would be the numbers of my sequence here. So if I set it up like this, I'll let this be my x-axis, and I'll let this one be my y-axis. So at 1, the first number would be 5. At 3, or at 2, the next number would be 3. The third term of the sequence would be 1. The fourth term of the sequence is negative 1. And the fifth term of the sequence is negative 3. Okay. So when we are graphing, we're just plotting the points. Now, as you can see, if I were to draw a line through this would be a linear relationship. Arithmetic sequences will always have a linear relationship between the points. Okay? But as far as graphing goes, what we're going to do is we're just going to plot the points because those are the 5 ordered pairs that we'll be dealing with in the graph, the first 5 terms of the arithmetic sequence. Here it says find the next 4 terms in the arithmetic sequence. So I have the first 3 terms. What am I doing? Well, it looks like I am going through and subtracting 6/4 each time, right? So if I subtract 6/4 each time, the next 4 terms in the sequence would be negative 13/4. Minus 6/4 would be negative 19/4. Subtracting 6/4 again, negative 25/4. And negative 29/4. Those would be the next 4 terms in my sequence. Okay, arithmetic sequence because the common difference is going to be a negative 6/4. How about this one? If a marching band has 1 member in the front row, or the first row, 3 performers in the second row, and 5 performers in the third row. If this pattern continues, how many performers will there be in the 10th row? So as you can see, we have an arithmetic sequence again, right? We have 1, then 3, then 5 in the third row. So I'm adding 2 each time to the previous row. So 7, 9, 11, 13, 15. Where are we at here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10th row must have 19 members. So 10th row will have 19 performers. So that's a little bit about arithmetic sequences. Let's go through and talk about a geometric sequence. A geometric sequence is a pattern of numbers with a common ratio. So in this case, I have 3, then I have 6, then I have 12. So as you can see here, the common ratio would be 6 over 3, which is 2, or 12 over 6, which is 2. So basically with geometric ratios, what we're doing is we're multiplying the previous number by a constant value. In this case, we're going through and we're multiplying the previous value by 2 each time. So the next number in this geometric sequence would be 24, and then 48, so on and so forth. So we're doubling the previous number. So if I'm looking at the geometric sequence here for 8, 20, 50, 125, well, the geometric sequence, the number that I'm multiplying by doesn't pop out right away to me. But I can come up with that by taking the ratio of the new number to the previous number. So basically here, 20 divided by 8, right? 20 over 8 would reduce to, take a 4 out of both, and that would be 5 halves. So what I'm doing is I'm multiplying the previous number by 5 halves. Would that work? 8 times 5 halves would be 40 over 2, which is 20. Okay. 20 times 5 halves, that would be 100 over 2, which is 50. So we do have the pattern. Okay, so here, which one is a common geometric sequence? This is a common geometric sequence, and the ratio is 5 halves. That's what I'm multiplying by. Let's try the blue sequence. In this sequence, we have 18, 32, or 30, 42, and 54. So if I'm going through and I'm looking for a common ratio, I could go 30 over 18. 30 over 18, that would reduce to 5/3. Okay, so am I multiplying by 5/3 each time? Well, 18 times 5 divided by 3 would be 30. If I take 30 times 5, that's 150 divided by 3. 150 divided by 3 should be 50. Ooh, that's not the case. So this must not be a geometric sequence. Well, if it's not a geometric sequence, is it an arithmetic sequence? Let's see here. I'm adding 12, adding 12, adding 12. So yes, this is a arithmetic sequence. So which one of these is a geometric sequence? This one's not a geometric sequence. Not a geometric. It is actually, it is an arithmetic sequence. How do I know that? Because I'm adding 12 each time. Okay? So hopefully that'll show you now the difference between a geometric and an arithmetic sequence. Geometric, I'm multiplying the previous number by a constant value. Arithmetic, I'm adding or subtracting a number from the previous number. So let's look at this geometric sequence here. Find the next 3 terms of the geometric sequence, then graph the first 6 of these. So what is the geometric sequence here? Well, it looks like I'm going to take the ratio 15 over 10. That's going to be 3 over 2. So the scale factor here, what I'm multiplying by each time, is 3/2. So if I multiply 15 times 3/2, I'm going to get 22.5. If I take 22.5 and multiply by 3/2, I'll end up with 33.75. So I'm multiplying by 3/2. My next three terms would be 33.75. Then I'll multiply that by 3/2, or 1.5. 50.625. Let's multiply that by 1.5. And I'm at 75.9375. And I just needed the next three, so that should take care of it here. Those are my next three terms in the sequence. Okay, now we got to go through and graph. So looks like my largest number is going to be 75. So what happens if I go by 5s on one axis, and we'll go by 1s on the other axis? So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. There's 75 there. So we'll write here by 5s, and this one's going to be by 1s. Okay, so your first point would be 110. Second point is going to be 215. 3, 22.5. At 4, I'm at 33.75. At 4, I'd be at 50.625. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 0.625. And then at 6, I'd be at 75.93. So 6, I'd be at 75.93. There's 75.9. Okay. So as you can see here, this is kind of like an exponential a little bit, or a parabolic curve. You're actually increasing fairly quickly with the values as I go to the right with each geometric sequence. Okay. So then it says, how does the graph of an arithmetic and a geometric sequence compare to each other? Okay, so on the bottom here, how does it go through and compare? I'd write an arithmetic sequence increases at a linear rate and a geometric sequence increases much quicker. Okay? So now we're just going through in example 5 and determining if we have an arithmetic sequence, a geometric sequence, or neither, and then explain the answers. So in looking at part A, it looks like I'm multiplying each term by -2. So 6 times -2 is -12. -12 times -2 is a +24. So this would be an example of a geometric sequence. In part B, it doesn't look like I'm adding anything because my numbers are switching back and forth between positive and negative, so the only thing that it could be then would be a geometric sequence. If it's a geometric sequence, that means I have a common ratio. So if I go -5 divided by 2, and I multiply by 2, I would get -5. What happens if I multiply by 8? Or I'm sorry, multiply by -5. Will I end up with 8? Okay. And that would be 25 over 2, so I don't end up with 8. So I don't have the common ratio. Therefore, this is not a geometric sequence either. So this one's going to be neither. And in this one, I see that I'm subtracting, it looks like I'm subtracting 12 each time. If I subtract 12 from -13, I'm at -25. -25 minus 12, -37. -37 minus 12, -49. So this would be an example of a arithmetic sequence. And it's an arithmetic sequence because I'm adding or subtracting the same value each time from the previous number. Okay? So that'll conclude the notes then for section 11.1, talking about sequences. And really we're looking at the difference between an arithmetic sequence and a geometric sequence in this section.